So the last class we had seen lens maker's formula. So 1 by f is equal to n minus 1 into 1 by r2 minus r1. That's the lens maker's formula. And we had generalized when we substituted for the object placed at infinity and the image formed at focal length. If that condition has to exist, then we can also say 1 by v minus 1 by u is equal to 1 by f, because when we solved it, the RHS didn't change, so we can keep our LHS equal. So that is another formula, formula that represents lens formula, or you can just call it as lens formula. The other one is lens maker's formula. Now we will go to the magnification of a lens. So just like we did for a mirror, we will draw a ray diagram of an object AB placed in front of the lens and an image of it which is formed, and then solve it to get magnification. So magnification of lens. Once again, we are going to do it for a convex lens, and you know you can try it out for concave lens, or it is going to be the same for concave lens as well. Now for doing it, let's draw the figure first. So you have a convex lens, you have an object placed, we will have the focal or length of a convex lens. Now a ray diagram going through that, parallel to the ray goes through the focus, and a ray going through the center of curvature remains to go through the center of curvature. They meet at a point and we have our image there. Now depending upon where you place the object, it changes. So you can say A, B, or we will keep it as O, O dash, and same way you will have I dash. So this is how the figure is, and we will consider, let's say this is the center of curvature, so it is supposed to pass like this. Okay, this is the center of curvature, I take it as C. Now we will consider two triangles, O dash C and I dash C. So when you consider both of it, what do you get? They are similar triangles, so you can compare the sides. So I am going to compare the sides. We will write I dash divided by O dash. So we have considered triangle O dash C and I dash C. So I dash by O dash can be written as, so corresponding to this, it is CI divided by OC. Now I dash and O dash can be written as H2 and H1 or Y2 and Y1. It's up to you. So we will take it as H2, this is height H2, this is H1. So H2 by H1, both of it. H2 is in the negative direction, so we will take minus H2 by H1 is in the positive direction, so we will keep it as H1 itself. Now CI is the image distance that is in the positive side, so plus V, and OC is the object distance in the negative direction, so you will take it as minus U. So we have our lens, an object placed, an image formed. We considered this triangle and this triangle, they are similar triangles, so we compare the sides. I dash divided by O dash is equal to CI by OC. We substituted with sign conventions for them. Now magnification, what is, I have already told you while doing mirrors, magnification means height of the image divided by size of the object. So you can say it is, magnification is actually H2 by H1. So from this we can write H2 by H1 is equal to, minus and minus goes off, so you will get V by U, which is equal to magnification. So magnification of a lens is V by U. H2 by H1 is common, even for a mirror or for a lens, magnification means H2 by H1. But here it is V by U. There is no minus. For a mirror, it was minus V by U. So this is basically the magnification formula. Now magnification formula can be written in various forms. We will try one or two more. So the general formula, I am writing it, m is equal to v by u. Now let's consider the lens formula, that is 1 by v minus 1 by u is equal to 1 by f. V by u is magnification. So I am going to multiply throughout with v. Okay, when I multiply throughout with v, multiply with v. So what do you get? V by v becomes 1 minus v by u is equal to v by f. So from this I am keeping v by u because v by u is equal to m, or I can write 1 minus m is equal to v by f, or you can say f is equal to, we can say from this m is equal to 1 minus v by f or f minus v divided by f. This is one formula for another formula for magnification, that is m is equal to f minus v divided by f. So what did we do? We took the lens formula 1 by v minus 1 by u is equal to 1 by f, and in that we multiplied throughout with v and we solved it, just mathematics, we solved it and we got f minus v divided by f. So I write one more equation of m is equal to f minus v divided by f. Now we can, just like we did for the previous one, we can also divide throughout by u, the same lens formula. So 1 by v minus 1 by u is equal to 1 by f. If I multiply it throughout by u, we will get u by v minus u by u, that is 1 is equal to u by f. So what happens? U by v is actually inverse of magnification. So you can write this as 1 by m minus 1 is equal to u by f. Now when you solve that, what do you get? You will get 1 by m is equal to u by f plus 1, or you can write u plus f divided by f. This is 1 by m. So what is m? M is equal to f by u plus f. So we have 3 equations as of now for magnification. So any of these formula can be used in any numerical that you get. It need not be always v by u. You may get a question where f is given and magnification is given and you have to find v. Then you can use this formula. So anytime you need not remember them. If you can't remember, anytime you can just substitute it in the general formula. Remember 2 things. One is multiplying throughout with v, the other is multiplying throughout with u. So that is magnification. Now we have one more small concept left, that is power of lens. So power basically is always the reciprocal of focal length. The reciprocal of focal length is called power of a lens. So power of a lens, P, we represent it by P, and that is 1 by F. Power is equal to 1 by F. Now when we immerse our lens in liquid, it need not, in any liquid, it need not be water, I am talking about a general liquid. Sometimes the focal length increases, sometimes it just not change, and sometimes the nature of the lens itself changes. That is, a convex lens may act like a concave lens. So when you immerse the lens in a liquid whose refractive index is less than that of the material of the lens, that is, let's say glass and the liquid is water. So the refractive index of the material of the lens is greater than the liquid, or the refractive index of the liquid is less than that of the material of the lens. In that case, the lens's characters doesn't change or the nature doesn't change, but what happens is the focal length increases and hence the power decreases. So when you dip lens in a liquid whose refractive index is less than that of the material of the lens, then the power, what happens to the power? The power decreases. Then if you immerse it in a liquid whose refractive index is equal to that of lens, then the power becomes infinity and the lens becomes invisible in that liquid. So, if it is equal, it becomes infinity and the lens becomes invisible. Now, the third option is you are placing it in a liquid whose refractive index is greater than that of the lens. If it is greater than that of the lens, then what happens? The nature of the lens itself changes. A convex mirror or a convex lens becomes a concave lens, or it starts acting as a concave lens. So, three options. One is material of prism. So, let me say refractive index of the lens and refractive index of the liquid and lens. If the refractive index of the lens is greater than that of the liquid, then focal length and power, focal length increases, power decreases. Next is n of lens is equal to n of liquid. What happens? Power becomes 0 and the lens becomes invisible. The third one is n of lens is less than n of liquid, refractive index of the liquid. What happens? The nature changes. Nature changes. That is, a convex becomes concave. So, that is about the power of the lens. Thank you.